because the x is inside of a fraction. So I want to graph this one. The first thing I want to think about is, do I have vertical asymptotes? Do I want to have horizontal, or do I have horizontal asymptotes? And what is my x-intercept? So let's go back to our rules. The x-intercept is the real zero of the numerator. Look at our numerator. Do we have any way that that numerator could be zero?
No.
No, there's no way one could be zero, right? So there's no x-intercept. So what this tells me is my graph is not going to be on the x-axis at all because there's no x-intercept. Okay, let's think about the vertical asymptote. Is there a way that x, or that 0, could go on the bottom? Yeah. If what? X is 0. So our vertical asymptote is at x equals 0. So what I want you to do is take the red colored pencil then and put a dotted line through x equals 0. And I wrote it up in the notes, but it probably didn't make sense then. But what this vertical asymptote tells me is the graph is never going to cross that line. And the graph is going to look different on this side than it does on this side. Okay, horizontal asymptote. Horizontal asymptote, we look at the degree of the polynomial. So x to what power? This is x to the first power. What power is x to on the top? X to the 0 power. So this time the x is to a smaller power in the numerator. And when x is to a smaller power in the numerator, our asymptote is at y equals 0. Every time. If this degree is smaller than this one, it's always at y equals 0. So take a green color pencil, and at y equals 0, we're going to have a dashed line. Okay, let's graph this. So we're going to graph it by just making a table of values. I'm going to pick numbers for x and see what I get for y. Let's start off by picking 0. What happens when you put a 0 in for x? What's 1 divided by 0?
0. No solution.
Not even no solution. It's undefined. And if you put that in your calculator, you're going to get the word error. So this one's undefined, so there is no 0 on this one. And that makes sense because that's where my asymptote is. So I want to try numbers on this side of my asymptote and numbers on this side of my asymptote. So I'm going to try 1, 2, and see what that does. What is 1 divided by 1? 1. 1 divided by 2? 1/2. So let's plot those. 1, 1, 2, 1/2. Does that give me an idea of what the graph would look like? Not really. Kind of, but not quite yet. If I try it, I want to see what happens to the graph right in here. So I'm going to try 1/2 for x. What is 1 divided by 1/2? Take that and flip it, it's 2. So when x is 1/2, it's up here at 2. Now you can get a much better idea. What's going to happen if I put 3 in for x? Be what? 1/3. What about 4? 1/4. So what's going to happen to the graph the bigger my x is?
Smaller the y.
Smaller the y. It's getting closer and closer to that line, but never touching. So it looks like that on that side of the graph. Okay, let's try some numbers on this side of the graph, like -1. 1 over -1, -1. Try -2. 1 over -2, -1/2. So I can tell what that's doing. That's getting closer to this. I want to try one over here like -1/2. What's 1 over -1/2? -2. So that side looks like this. Yes?
This is on the purple, right? Is that right?
Nope, this one's not hyperbola, but you're thinking along the right lines. Hyperbolas will look like this, but not all these will be hyperbolas. Notice for the vertical asymptote, I used a red line. What does the color red mean?
Vertical asymptote.
Anger.
Oh my God.
Okay, let's go back to driving.
Stop.
Stop. So the red one means that the graph is going to stop and do something different. So anytime you have a vertical asymptote, the graph cannot go through it. Horizontal asymptotes are in green because sometimes the graph will stop, sometimes the graph will go right through on one side or the other. On one of the sides, it will stop and get close. The other side, it can do whatever it wants. Okay, it doesn't have to stop on both places. Type that in your graphing calculator, 1/x. You're going to want your graphing calculator today.
I do.
I bet it doesn't work.
Hit graph and then look at the table. Does your table look like this?
Hold on a second.
Okay. Does the graph look like that?
Yeah.
Yeah? Does your table look like this? Exactly. It doesn't have the 1/2. So on these graphs, because we're going to be trying things that get closer and closer to a line and never touch, we want our graph to not just go by ones. So let's change that. Do you remember how to change it? Yeah, table set, I think it's second window. And then if I were you, I would change that to either 0.5 or 0.25. So we can get a real close look. Did you find it?
The table start.
I think it's second window because it says table.
I did.
And then down where it says change of table, like the little triangle. Yep. And then you get a chart that looks like this. Do what?
0.5.
I would either go by 0.5 or 0.25.
Which one would you
Depends on the problem I'm working.
do?
Okay, let's do the next